Good morning, it's Dr. N here. Haven't seen you in a while. Decided to do an example on torsion today. So let's get to it. So a 200 millimeter diameter solid shaft transmits 1 milliwatt megawatt at a speed of 160 revolutions per minute. Determine the maximum stress induced in the shaft and the angle of twist over a length of 5 meters. Take the Young's modulus as 18 giganewton meters. So we know from mechanics that to calculate power, it is torque torque multiply by the angular velocity. So the first step of this question is to calculate the power. So we can see that there's a solid shaft. It transmits 1 megawatt. So we've got 1 times 10 to the 6. Remember, we do need to convert this. So the prefix 10 to the 6 represents mega. And then you've got your torque, which we don't have. So T times the angular velocity. So the angular velocity in this case would be 160 times 2 pi divided by 60. That's the conversion that you would need to do. We would then be able to rearrange that for the torque. So T would equal 1 times 10 to the 6 times 60 divided by 160 times 2 pi m. So if I quickly just do this on my calculator, that gives us a torque of 5,959,683 Newton meters. Do remember your units. It's extremely important, especially if you're doing an exam. In an exam, you tend to lose 1 to 2 marks on a question like this for forgetting the units. So it is extremely important. Well, so we know from the torsion theory that we covered in lecture that tau, which would be the shear stress, equals the torque multiplied by R over your moment of inertia, polar moment of inertia, J. So to be able to calculate J, we know J would equal pi d to the 4 over 32. So if we then just substitute those values in that we've got in the question. So pi times d, which would be 0.2. So remember, we need to convert that into meters. 0.2 over 32. Remember, to the power of 4. That then should give you a value of 38.0 times 10 to the 6. Obviously, that's not the end of the question. We're wanting to work out the shear stress, so just gonna work it here where there's a bit more space. So tau equals the torque that we've worked out to be as 5,959,683 multiply by R, which in this case would be 0.2. And then if we divide that by J, that then should give us that should actually that would be incorrect. If I redo that on my calculator, that should pi times 0.2 to the 4 divided by 32. That should give us an answer of 1.5707 times 10 to the minus 8. We would then obviously substitute this value into here. 1.57 times 10 to the minus 8. That would then give us so that would then give us 38 times 10 to the 6. Then to the 6, and then that would, again, units would be Newton meters. Then from so we just separate that. So if that, mark that as step 1 to work out the torque. Step 2, use the torsion theory to work out the shear stress. We then can proceed to work out the change in theta, and we can do this by using the relationship T over J equals J theta over L. We will be able to rearrange for theta, so theta would in this case equal TL over J GJ. So so if we now substitute the values into this revised formula, we would then be able to get the angle. So in this case, we know the torque, which is 4959683. Then if we times by 0.1, which is, if we times by 5, which is the length, and then divided by G, which is obviously 80 times 10 to the 9. Again, we would need to convert it into giga. 8 times 10 to the 9. And then if we multiply that by what we've worked out for J, which is 1.57 times 10 to the minus 4, that would give us a value for theta of 1.36 radians. But we could also convert that into degrees if we wanted to, which would be equivalent to 0.00237 degrees. So yep, so this is a relatively straightforward example in order to solve a simple torsion problem where a shaft is subjected to stresses induced by a variety of parameters. It wants us to work out the maximum shear stress induced in the shaft, and we've done that by using the correct formulation from the typical torsion theory in order to do so. Now I intend to do some further examples on torsion in due course. If you could like, share and subscribe, that would be great. Thank you. Look forward to seeing you for the next one.